Hi everyone, we're going to use the definition of the derivative to find the derivative of each function. Here's the definition. In my class we have practiced with just the difference quotient. This part is called the difference quotient. Basically it's the slope formula based off the secant line. And I do have a video of where this came from, this formula comes from. Anyway, so basically what you're going to do is take the derivative of this. So we're going to write this, and then you're going to write this equals the limit as h approaches a very small number, gets closer and closer to 0, and you're going to write your 2 and then plug in this part, then minus your whole function, which is 2x, okay, all over h. Then you have to keep writing this limit. Calculus teachers will get really mad if you don't. So you get 2x plus 2h minus 2x over h. And simplify. These zero out, so 2h over h. And I'm going to keep this on the same page. Limit, this h gets very small, of 2, and the answer is 2. Okay, because there's no x to plug in, or h to plug in. Okay, the next one we have is f of x is 7x plus 4. So the derivative of this is going to be the limit as h approaches a very small number, gets smaller and smaller, or tends to 0. Okay, so this equals the limit as h approaches or tends to 0. Now, what you're going to do is write this function down minus your whole function, which is 7x plus 4. And what you're going to put in everywhere there's an x, you're going to put in x plus h. This is going to be all over h. So this equals the limit, and you just distribute. Now, if you do this enough, you're going to notice that everything's always going to cancel out, not unless it has h in it. So this cancels out, the 4's cancel out, so the only thing you should be left with is something with the h in it. So that's going to be the limit as h tends to 0 of 7h over h is equals the limit as h tends to 0 of 7, and that equals 7. Okay? The next one we have is negative 3x. So we have f, the derivative of f is the limit as h tends to 0, gets smaller and smaller, of f of x plus h minus f of x over h. So we're going to take this, that's my f, and you have to keep writing this limit thing. H tends to 0 of negative 3, and you input x plus h minus your whole function, which is negative 3 of x, all over h. If we did it right and we simplify, we should only be left with something with the h with it. And we are. These two cancel, so you're left with only the h on the top. Well, something with the h attached equals the limit h tends to 0 of negative 3, which just equals negative 3. Okay, the next one, we have this one, so the derivative equals the limit as h tends to get really small, of f of x plus h minus the whole original function over h, which equals the limit as h approaches 0 or tends to 0. And I just write down my -4, leave a blank for my x, and write my -9. Then you're going to subtract the original function all over h. And you're going to just input x plus h here. And then you clean it up, distribute, simplify. And what happens here is everything should go away except this. Since the h's cancel, there's nowhere to put the zeros, so the limit as h tends to 0 of -4 is just -4. Okay, I think the last set's going to be more complicated. Okay, here we go. So basically I'm going to write this. So this is the, why did I put inverse? So this is the derivative. All right, so here we go. This is going to equal, and what I do is I write 2 minus your whole function. And everywhere there's an x, we're going to input x plus h. And we should have closed that up. All right, now when you first do this, you're going to square that out, and you should know your factoring rules by now if you're at this level. Distribute and subtract everything, or negate this last piece. And we have to, oh, we should keep writing. I don't want to make the calculus teachers mad. Limit as h approaches 0. And then to write it again. Limit as h approaches 0. So you're going to get 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2x squared minus 5x. Now let's look at this. Everything should cancel except the things with the h's in them. So you notice these two cancel. The 5x minus 5x is 0. And we're just left with terms with h. And basically all of this should have been over what? H. All of this should have been over h. I forgot to put it. All right. Now what I'm going to do on this one should have all been over what? H. What I'm going to do, instead of putting it all over h, is put it under each piece. So that way you don't forget to divide each piece by h. And you're left with 4x plus 2h plus 5, because that will cancel, these will cancel. H squared over h is just h. Now what you're going to do is input the 0 for this h. And I'm going to go ahead and do it here to save time. So everywhere there's an h, put 0. So what you're left with is the limit as h approaches 0 of 4x plus 5. So the limit is 4x plus 5. Okay, one more. And you're going to have to take my word for this one. I'm going to show you how to do this. So we're going to do the derivative of x, which is going to be the limit. And I'm going to go ahead and start writing this. H approaches 0. Everywhere there's an x, I'm going to put parentheses. Then we're going to subtract the whole function. X cubed plus 5x squared plus 6. All right. I'm running out of room there. Okay. Now, what we're going to input is the x plus h. And I'm going to go ahead and divide this all by h. Now, this is the part you're going to take my word for. If you had sequences and series, and you know Pascal's triangle, you know this is going to be 3x cubed plus, no, it's just going to be x cubed, sorry about that, plus 3x squared h plus 3xh squared plus h cubed. And then we have to do this part plus 5 times x squared plus 2xh plus h squared plus 6 minus your whole function. All right, all of this would be all over h. Okay, so let me try to make it a little smaller. So the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed. Now go ahead and distribute plus 5x squared plus 10xh plus 5h squared plus 6 minus x cubed minus 5x squared minus 6 all over h. Now, let's cancel out what we can. These two cancel. My 6's cancel. And everything that should be left should have an h in it. I don't think any of those can cancel out. So let's just write that out. Now, there's nothing we can add here because they're all different. And instead of dividing the whole thing by h, I'm just going to divide everything, each piece by h. That way I don't make a mistake. And I'm going to try to squeeze it in here. So you're going to get, these cancel. So you get 3x squared plus 3xh plus h squared plus 10x plus, this should have been an h here, plus 5h. Because those h's canceled and then I reduced. Now what you're going to do is everywhere there's a h, you're going to put 0. And I'm going to go ahead and put it on here. So I see an h here. That's going to be 0 because that tends to 0. This is going to be 0 squared. And this is going to be 0. And what happens is this gets knocked off. These two get knocked out because they 0 out. And you're left with 3x squared plus 10x. So the limit as h tends to small is 3x squared plus 10x. And that's your final answer. And that's all. Thank you. Have a nice day. Bye-bye.